Okay, welcome to today's class. Okay, so I just want to talk about what we'll be doing today. So today we'll be moving on to the final milestone for the course. We'll start teaching the final milestone. That will be arrays. So basically, hello, yes, Melody, you there? Yes, okay. Okay, so we can do everything we need to do in programming with what we've learned without arrays. So using variables, pointers, and files, we can do everything. But arrays can make things a little bit simpler sometimes, or easier or faster, the program to run. So I'm going to talk about what we want to do this week, next week, and final week. So you get an idea what our goals are for the next 3 weeks of our course. So I hope to start today by taking up milestone 4, the VP diagrams on quadratics. We also want to take up flow to finish the root problem, your homework. That's section 5, page 52. Then we'll have a chance to retry milestone 3, milestone 4, or first try for milestone 5. Okay? And there's basically 9 students doing milestone 3, 18 milestone 4, and 14 milestone 5. Okay? Then we'll talk a little bit, moving on, we'll talk a little bit about theory, arrays as a data structure. We'll talk a little bit more theory. And for homework, I'm hoping that you'll read this stuff from SDBA on arrays this week. Okay? Next week, I'll take up the milestone 4 and the first milestone 5. Try. Then we'll review the theory, arrays as a data structure. We'll try to apply arrays to following objects and give you a chance to use arrays for the objects problem. We'll take up the objects application. Then we'll do a retry for the milestones. And then go home, homework, basically prepare to pass milestones or read about records as well. Final week, we'll take up some milestones, then you'll get a chance to retry. We will then break into small groups. Each TA will teach a different milestone, or you can mentor someone at different milestones to get the last milestones. And then we'll break. So basically you'll have 2 chances during final week to do milestones. Okay? And then after that, we'll move on to continue on in the following weeks with records, with a few chances to redo milestones again. So I hope this gives you an idea what we want to do in the next few weeks. Secondly, marking. So as you can know, there are 6 milestones, right? That gives you 90 points. There are also 10 points for mentoring. Remember that you need to, as you teach, you can gain the extra 10 points. If you decide not to do any mentoring marks, your top mark is 90. Okay? So if you pass all tests, your mark will be 90 if you do not do mentoring. Okay? So mentoring is the remaining 10 marks. Stamps will be useful for bonus marks, assuming if you are at between milestone 4 or milestone 5 passed, but not milestone 6 passed. If you don't pass milestone 4, there will be no additional marks for stamps. You need to pass milestone 4 in order for stamps to count for marks. Okay? Are there any questions on that? I see none. Okay, let's look at the first. I want to first take up the MP4 quadratic. Okay, let's look at the question. I'm going to do it in a short. Okay. All right, there. Okay, I'm going to try to make it. Okay, too big. Okay, where is it? Here he is. Make him so he takes up not too much room, so you can see what question we are trying to solve. Is this guy? Okay, let's copy it, and I'll move it to. Okay, I'll do to my Blackboard. Okay, Blackboard here. Copy to my, there's my UML. Okay, But I don't want to do very pointer diagram. Come on, copy, text, so we can see what we're doing. Huh, not copying. Shoot, okay, Control S. Try it again, Control C. Control V. Oh, it doesn't like to copy. Okay, it's copying way up here. Okay, fair enough. It's not copying the way I would have liked to have copied. Okay, Control Z. Let's try to do it to Notepad first then. Okay. So we'll copy first into Notepad. Come on. No update. Okay, copied into Notepad, Control C. Let's now try to copy into here. Let's get rid of that junk. Okay, copy to here. Okay, so now he's happy. Okay, good. Close this. Open this. All right, so we can all see clearly what we are trying to do. It's this little problem here that we're trying to do. So I have two functions, main and solve quad. Okay, so I'll pull a main. There's my main, and I need my function, so I'll make my function here. So this is solve quad, solve Q, solve, that's not spelled right either. Okay, so, okay, I'll just, oh, never mind, Okay, what have I done now? Good grief. That's not what I want to do. I want to make this stuff small. Okay, good. All right, get rid of this thing up here. Good. Okay, so solve is there. Main is here. Main as 1, 2, 3, 4, 5, 6 variables. Okay, so I'm going to need 6 variables. Let's move. Okay. And they're all integers. Everything is an integer. Okay, so we know we want to make sure we're going to use integer container. My version. Okay. 1. Good grief. It's not cooperating very much today, unfortunately. C, B, 2, 3, 4, 5, 6. Okay, that should be all 6 of them down here. 6 containers. Do this thing a little bit longer. Okay, the first container is A. Then we've got B. Then I've got C. R1. R1. R2. And solution. Okay, there's my containers set up, and within them I've got 5, 6, 1, 2. Okay, moving over here so I get my, where's my 5? Okay, there's a 6. Okay, I'll put my 6 across at least. 6, arrange order, send to front, bring front. Okay, 6. This guy is going to be 5. My next guy is going to be 1, and then 0 and 0, right? 1. 0. Another 0, and the solution is 0, 2. Okay, so solution is 0. So that's this guy. Now let's set up solve. Solve is also getting 3 integers and 2 pointers coming in, plus then one double D when it's inside. So I've got a few points. Okay, I'm starting with 1 integer, 2 integers, 3 integers. Okay. 1 integer, 2 integers, 3 integers, 1 pointer, come over here, pointer, 2 pointers, and, sorry, I making it any longer, and I've got one more in, okay, that should be enough right now. And the next line I'm going to get one more. Okay, so this is my initial thing. So when the function is, I go to this line, the function is called. I transfer the value of a into int a2. Okay, oops, I forgot to name them. a2, a1, a0, pr1, pr1, and pr2. Okay, so a2 gets the value of a. So this number comes across to here. a1 got the value of b. I just copy the value. a0, another variable, gets the, just in case it gets the copy transferred there, get a copy. pr1, I'm giving the address of r1. Okay, so I need to get him down here, so r1 address. Okay, pr2 gets r2 address. Okay, so I'm finished up to this line right here. Now I'm going to go to this line, and I'm declaring a new d and doing some multiplication and put some numbers into it. So d, let's get all this. I'll move you down. I'm declaring d. That I'm getting the value out of a1, 5 times a1, 6 times 6, minus 4 times 5 times 1, minus 20, so d should be 16. Okay? If d is less than 0, return 0. It's not less than 0. So I need to continue on. PR1 is going to be equal to this, basically minus a1 plus the square root of, and PR2 should be this. So you immediately might think I should now, okay, this minus a1 is 6. This will be, I'm just going to do the calculation over here before I do anything. Okay, so this one is going to be minus 2, and the other one is going to be, right, minus 2, okay, minus 6 plus the square root of 16 is 4, that's 2. 2 divided by 2 times a2. 2 divided by 2 times a2 should be 0.2, right? Okay, and this next guy is going to be minus a1 minus the square root. Okay, that's going to be minus a1 minus 6 minus 4 minus 10. Minus 10 divided by 10 is going to be equal to plus 1.0. Now, at this point, it says this is where, so this dereference means try to put this value into R1. Okay, we've got a problem though. This is an integer spot. I declared a pointer to the double. Okay? So, it's going to try to put a number in there. But it's not going to be 0. It's going to go to 0. Okay? It's not going to be able to put that in there because it's an integer container. It can't put in a double that it calculated. This guy is also a double. I've said he's a pointer to a double, but he's an integer. He also can't put it in there. Okay, so we'll just be left with 0, 0. Now, if this had said double, okay, and we made this double, 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 then I would have been able to do that. I would have taken this minus 0.2 would become to here, minus 0.2, and this would end up being plus 1.0. Okay? So if this is the code, this would be the answer. But since I had int here, that would not be the end. It would be 0, 0. Okay? But we gave it to both ways. Both ways. If you got 0, 0 or you did minus 0.2, 1.0, I gave you the marks for that. Okay? But this is just to give you some knowledge on this in terms of making, you must always make sure your pointers are the correct type. Okay. So that's our first step. Okay, next, we want to go from flow to the finish the root problem. Okay? Let's move across to there then. Where's my SDBA? Chrome. Okay, Chrome, where'd you go, Chrome? Okay, this guy I'm going to finish, close you right now. Chrome, we're finished with this. Okay, Chrome, and we want to go to sdba.info. Okay, we're going to look through the flow one. So we're going to discuss, so we've done up to here, variables, pointers, flow, but we have not yet walked through our flow code. So let's look through our flow code in moving from the pointer to the loop function. So we're taking up the homework. Huh? What is it? Oh, shoot. Okay. Stop that. Why is it trying to go to optic? I don't want it to go there. Even I type correctly, it still is not doing what I want it to go where I want it to go. ROOT. That's where I want to go. Okay, here we are. Okay. And we downloaded, sorry about that, minor mistake there. I will go get that fixed. Downloads. Okay. Oh, we downloaded a whole bunch of this guy. Okay. Okay. So, okay. Okay. Let's start to take up our problem here. Okay. This is our program right now that we looked at, that you were modifying, was this guy. We got a small value of x, a big value of x, we calculated the mean, and we calculated the equation y equals x squared minus 2. But this is quite stupid and boring to do it this way. Us deciding the next value of x and y to try, so we need to try to automate it to add repetition. Okay, so in this case, we want to first of all start by modifying the UML. That's the first step we need to do, is modify our UML before we do anything else. So this is our current UML. We fixed p. We said p must be greater than 1 for this algorithm to work. We input xs, it's too small. xb, that's too big. We do the calculation of the mean, calculate y equals x squared minus p, output x of y, and then we make the decision on our next sx and xb. We use fprintf function to do the output. We created our own function cmean to do the calculation of the mean, our own function equation, and we use get float prompt to get the two inputs. Okay, so that's how, and we put this all into one big function main. So this is our architecture of our code. So now we want to not output x and y. We want to say, okay, based on this mean and y, let's choose our own next values. Question? Question? You have a question over there? Question? Yo wen ti ma? Okay. Kui wen, may wen ti. Okay. All right. So basically, we now want to make the decision ourselves. So we're going to input p. We'll let the program choose the first small x and the first large x. we will then enter into our loop. If we're not close enough yet, we will enter into the loop, calculate the mean, calculate x squared minus p. If y is less than 0, that means our guess is, our middle guess is going to be on, okay? If y is less than 0, it means we can then make xs x. If y is greater than 0, our xb will be x. Okay, in other words, our x is still too big. If it's this way, it's going to be, we have to do, our xs will be x. Okay, which one we choose? We will then loop around. If xb minus xs is greater than epsilon, we will keep looping. So now we've got a loop generating here, and finally we will output x. Okay, so we can then, so in order to do that, we have to decide functions to use first. That's our pseudocode part. But since this is relatively simple code, I'm not going to do the pseudocode part. I'm just going to show us how I'm going to use my functions. Okay? These are functions I'm going to use already. fprintf, output x, cmean equation. I will probably use get float prompt here to get my input p. Okay? So I'm still using the same functions I used before. But I'm going to create a new function, croot, to do all this work. Okay? So croot is going to do setting of these parameters. Croot is going to do the loop is going to be in croot. And so main, and there's only going to be one input. And so main is going to be the big program. It will call get float prompt. It will then call croot. Then it will call fprintf. So it'll be a very nice, so this will be our architecture for our program. So given this sort of architecture, let's close that guy. I don't want him there. Let's move him over here. Okay, there's my architecture, and let's quickly run through some coding. Okay. Okay, my code sits over here. Come on, fit nicely. Come on, snap. I don't want to. I want the whole page, please, 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 please. Down. Okay. File, save as. I don't know. Next.c, whatever. Oh, okay, doesn't want me to save there. Oops. I bet I'll move it to my directory SDBA then. Save. Okay. All right. Okay, let's start. Okay, I'm going to use, I've already decided on the functions I want to use, so let's start getting my function prototypes again. I'm going to include jinlive.h, right? Because I'm going to use get float prompt. I'm going to create a function croot, so I need a prototype for that, and it's going to be double croot double, right? I'm going to just input p, and I want to output x. So it's just going to be quite simple. I'm going to use a cmean again, so that's double cmean double xs, comma double xb. Okay. Next function prototype, like function equation. Okay. Double equation, and equation is basically going to be all it needs to get p, right, in x. So double x, comma double p. I'm going to have to tell it what I want the root of. Okay, and I also am using fprintf, so I need a prototype for it. So I'm going to include std standard input output.h library. Okay, so I've got all my 5 prototypes up here. Now I can write my integer main void. So for integer main void, I'm going to need a few things. I'm going to have to input p, so I want a double p, and I want the root, right? So I'm going to probably have r as my root. Okay, what else have I say here? Oh, I want this epsilon here. So I can just set that here. I'll just define it. Define how good and accurate do I want accuracy. Maybe I'll define e as 1 e to the minus 10. Okay, nice small number. Or maybe I'll just EPS. Let's call it EPS, make it a little bit more like it. Okay, so I want to get the root from P equals get float prompt. Enter number 2, take square root of. Okay. Next, I'm going to just take the square root. P equals C root P. Okay. Actually, so when I look, okay. And then I want to print it. Okay, oh, not P, R, right? It's the root. I can do that, but I would just make it. So then I'm going to F print F, standard out. Maybe it's like square root of percent %LF equals percent %LF, and it's the square root of P is R. Okay, and return 0. Okay, so now I've basically got my functions done. My main function is finished. I'm getting the prompt. I'm calling root. I'm printing the output. Now I have to worry about writing the function square root. Double C root. Double P. All right. So, okay, now we want to see, okay, we're going to have to have a loop here. We need to get the minimum and the maximum. So let's start with double x too small, xb too big, and probably another x to be in between. Okay, so we'll start with xs is equal to 1, because we know p is going to be greater than 1, so xs equals 1, xb equals p, okay, xb equals p, and then we're going to have to calculate x. Alright, so I need x equals c mean of xs plus, xs and xb. I need to do the equation, right, to get my y. I'm going to need a y here too to see if it's y greater than 0. Y equals equation of x. We already wrote these guys before, and then we have to say, okay, if, okay, so this is going to be a while, so while, okay, so we have to have a while condition here. We're going to be looping, and what's our while condition? xb minus xs is greater than epsilon. So this way our UML is very helpful. We're going to do this. We're going to calculate x. We're going to calculate a new y. And we're going to check if y is less than 0. What do I want to do? xs equals x, else xb equals x. Okay, and then that's it. Okay, and I guess that's all my outside guy. Because I assume I already know what these guys are. So my C root is now return. I guess I can return whatever I want. I could return, I don't know, maybe the easiest way is to C mean, return XB, whichever, XB, XS. We're accurate enough. Okay. And we would just use the same mean as we had before. Let's rewrite it anyway. Oh, nah, let's copy it. I can't be bothered writing it anymore. Where's my Chrome? Okay, C programming is on. Okay, for R4. Okay, let's go just on I5 there. That's the one way I like. Okay, I just copy these two guys. Copy my two functions. And I'll go back to my here, put my two functions down here. Okay, there's my equation, there's C mean. Okay, looks like I've got, okay, my equation here is actually putting in two things because what I wanted the square root of. Okay, okay, y equals x minus p, well, we want the square root of. Okay, so I realized, whoops. Okay, why did I only have that there? My call is not the same as my prototype or my definition, so I need to fix my call. And now I should be able to try to compile it. Okay, where's my C? More info, run anyways. And we'll come across GCC minus C minus wall next dot C. See what errors I got. Oh, no errors this time. I'm amazing. Okay, next dot exe next dot o jinlive dot o since I'm using git flow prompt. Okay, looks okay. Next. Input number today, square root of 4. Square root of 4 is 2. Okay, next. Let's try again. Square root of 99 is 9.9487. Okay, fair enough. So program is running. I check for one more case to make sure it's working. Square root of 16 should be 4. Yeah, okay, program works. So I'm finished. I've now written a square root function in C. Let's now look through how the function works. I'll go back to this so we can understand the function again and understand our VP diagrams now. Okay, we ran our code, it works, let's analyze it. Okay, first two lines, information for the humans. There's my function prototypes. They are here. I'm going to replace wherever EPS occurs in my program, I'm going to replace it by 1e to the minus 10. And I've got a few more function prototypes that are in this file. Okay, main starts. Two variables are declared. Containers, p and root. My next line says calls get float prompt, which gets the floating point value and stores it as a 3 and a 1. Okay, square root, I'm going to take 3. I then call root. Root, I transfer the p across, so it's a copy. I create XS as being 1, XB as being 3, and I create two new containers, X and Y. Well, XB minus XS is greater than epsilon. Okay. I'm going to do this, and I can see basically it is, so I'm going to enter in and take the mean. I will then take call the equation. The equation is going to return 1. Y is y less than 0? No. So it jumps down to the else statement. So XB is now made to be equal to X. So this X value is put into XB. I then check again. Is 2 minus 1 greater than epsilon? It is. I enter my loop again. I calculate the value that's halfway between, store it into x. I call the equation to calculate this, and it gives me a negative number, 0.07 e to the 1. Okay, now I check, is y less than 0? The answer is yes, it is. True. So I do this statement. XS is now going to be equal to x. And I enter the loop again, and let's just assume that we got down far enough. And so I do square root is 0.15, I'm happy enough. I now print it, I call fprintf. Fprintf, remember, it gets standard output. It also gets it has a pointer to get this information, and it also needs the number that you want for root. And we print that. Okay. And that's our code. So if we're looking at where we are right now, we will now continue on to today's class. Next step is retry milestone 3, milestone 4, or milestone 5, try 1. So first we're going to look at milestone 3. What? I can just show them what it is. Yeah. Okay, yep. Okay guys, we're going to start with that. Okay. Alright, so we're going to first with milestone 3. So milestone 3 is to find the hypotenuse. And, okay, so if I'm going to do my UML, I would probably want to start with my UML. So my UML would, actually, I'm just going to write it down rather than go to the problem of drawing. So input A, comma, B. Right, the next was going to be, second part would be just calculate C squared. C squared equals A squared plus B squared. And third step would be just to print. Okay? That would be basically the UML, would be very simple. So let's just quickly write the code. So I'm going to include, okay, I'll start by including for my input imlive.h. I'm going to write my own function to the hypotenuse, so that's going to be double height, double A, double B. Okay, so we have the function prototype for the hypotenuse, and I need a function prototype for the print. Include stdio.h. Okay, and finally, then we start integer main void, and okay, I have to input both of them, so I could write double A, comma B, okay, double A, B, C, declaration of variables. A equals get float prompt. I would just do something like that. B equals get float prompt. Oops, spelling wrong. Prompt. B. And then I'm going to get the hypotenuse. This is a C equals height A, comma B. So our function call. Then we're going to call the function to fprintf, standard out, %lf, comma C. Okay, and then return 0. Okay, there's my call, so I'm calling get flow prompt, function to calculate the hyperbola, function to print the output. So I'm just calling for three different functions, so I need to write my function height definition. So it will be very simple. I need a new variable, so double C. So C, I got maybe C squared. I'll call it squared so I don't confuse myself. C squared equals A times A plus B times B, and then return C2. Okay, so this would be the complete program. We have our function prototypes, our function calls, and our function definitions. Okay, and that should be all of that guy. Okay, now we're going to look at the next one was a VP diagram, which is a little bit more challenging. And so that's why we want to look through that guy. Okay. So this time's VP diagram, I agree, is a little challenging, so we'll talk through it. M4 sum diff is the one. Okay, there's our functions. All right, so let's, I'll immediately pull my Blackboard up and try to start to look at that. Where's my teaching guide, my Blackboards? Here we are. Okay. Come on, Blackboard. Okay, look okay. This, I don't need this thing here. Let's narrow this down so we can actually see it. And then make sure my Blackboard is as big as possible. Okay, use as big as possible as I can. Come on. Okay. Okay, there's Blackboard. Okay. VP diagram. I have, first of all, check the question. I want it at line 11 of the code. Okay, so that means at that point, there's no longer these two functions. But I need to start at the very beginning if I'm going to get everything right. So what have I got in main? So I first of all put my main across, and I'll make my main big because he's the big guy I'm going to worry about. So main, there it is, everything in main there. And I've got J, K, N sum, and sub. So basically 4 variables. Oh, come on. One, 2, I need 4 of them. 3, 4. 4 variables. The first one is J, and he has 4 in him. My second one is K. She has 7. My third one is N sum. And it's got, I'll just put some random number in it. 666, 666. And sub, he's got some random number in him too. Let's just put him, okay, some random number. I then have, oh, now I've got some pointers. I'm declaring Rahim, okay, as a pointer. Okay, so I've got to get a pointer in there. And Rahim is getting the address of J. So Rahim's going to basically be pointing to J, so I'm just going to stick him right here. Rahim, there he is. He's pointing to J. And I've also got Michael. Michael, he's going to be pointing to K. M-I-C-H-A-E-L, he'll point to K. All right, so there's my main program all set up. Now I want to see what happens. First of all, I call calculate. Calculate takes J and K and puts them in its own distance. It also has 2 pointers, long sum and long sub. Okay, so I got to get 2 pointers and 2 numbers. Okay, let's get them here. I'm going to just copy these guys over right now. So okay, So here's calculate. He's got an A coming here and a B. So what did A get? A got the value of J, which was 4. B got the value of K, which is 7. Long sum. Okay, I've got a pointer here, sum. And what does he get? Sum receives the address of n sum. Okay, so I'm going to get another long line up. Okay, so he's going to be pointing there, and sub. Okay, this guy's sub. I'm going to call him sub. He's sub. The other guy. He's going to be pointing to the address of n sub. He gets the address of n sub, so that means he's going to be pointing to this place. All right. Now we do the calculation. Right side. A plus B. A plus B is 11. Dereference sum. So put it right here. Okay. A minus B. A minus B is minus 3. Dereference sub. So that means it goes to here. I place minus 3. And now I return. I go back to my main program, so this stuff disappears. Gone, bye-bye. Delete, delete. Okay, he's gone. And this is gone. This is gone. This is gone. Okay. I now jump to the next line, to line 10. Multiply by 2. I'm giving the address of Rahim. I'm giving Rahim. So Rahim, I'm not giving the address of Rahim, I'm giving the value in Rahim. So Rahim is pointing to J. So now this guy is also going to point to Ra is going to point to J. So I grab what did I do with my arrow? Deleted him, oh well. So this guy is going to be pointing to the same place Rahim's pointing to, so he's going to be pointing way over here to J. Okay? When he's pointing to J, now what does it tell him to do? Take the value out of the place, go to Ra. Where is he pointing to? He's pointing to J. Take the value from that memory location. Okay, I'm going to take the value. So I take the value of 4, multiply the value of 4 by 2, put the value that I calculate, 2 times 4, that's 8, put that back into the container that is pointed to by Raj. So this is now becomes 8. This 8 gets put over to there, right? So the 8 goes put back into here. And return. So Raj now disappears. So this is so at line 11 we're at this situation. Okay? The line at 11 we have an 8 in J. Okay? And that's basically how the program ends. Rahim pointing to J, Michael pointing to K with an 8, 7, 11, and minus 3. So you guys all doing milestone 4. Next time should be okay, right? Right? Yeah. Next time, no problem. Okay, great. I won't discuss milestone 5 until more people have passed it. Okay? We'll give you guys another chance to look at that. We want to make sure most people pass these early milestones. And then we'll get that. So next week, I'm sure everyone will pass these earlier ones. Okay? All right. We now are going to, it's now 5. Let's take about a 5-minute break, and we'll try to end 5 minutes early, okay? So, we're now moving into the textbook. Guys, it doesn't appear on their screen, so I don't know why. Okay, sorry about that. Okay, good. All right. Okay, so we're moving on the idea of arrays. So this is the first. So if we want to look at it in context, first of all, So data structures. So we're starting to talk now more about data structures. So we have, in C, we have a lot of different data structures. In general computer programming, we talk about arrays, records, linked lists, circular linked lists, stacks, queues, trees, and graphs are all different data ways we can structure data in languages. So within C, we only have arrays and records are built in. Everything else we have to build for ourselves. They're not built in. We must create everything else. So we need to create graphs. We need to create neural networks. They're not built in. Okay? Or we find somebody's library who's already done it for us. So there are 8 basic data structures. 2 of them are in C. So in this unit, we'll be concentrating first of all on arrays, and then we'll discuss records. So in Chinese, okay, oops. Yes, run Chinese, please run Chinese, okay, yes. Okay, so give me our English for Chinese translation so you know what we are talking about. This is done by some other students, okay. Things that you might find useful, this one we don't need yet. Okay, arrays and records, these are various Chinese terms for all the English words we will be doing. Okay, and we are thankful you are going to read all the Chinese for us. Thank you.
标注全靠配置，初始化，静态记忆体配置，动态记忆体配置，固有的标签资料栏。
Okay, thank you very much. So those are great. Thank you. All right, great. Okay. All right. So what is an array? That's our first thing. What is an array? An array is a grouping of data of the same type. So everything in the array must be the same type. For example, an array can be composed of variables. But each variable, if it's a variable, every variable in the array must be fixed point. Or every variable in the array must be floating point. In other words, we give, or it could be an array of pointers. Okay? As long as everything in the array is the same type. Okay? So why do we want to use arrays? Arrays allow us to store a lot of related information together. For example, if in the acceleration of velocity and acceleration, we could use an array to hold all the time and distance coordinates together. Then we could just run like T1, D2, like this all the way up to Tn, Dn. So if we did 1,000 measurements or something like that, we could just put an array of these measurements. Then if there are only 2 data points, we don't need an array. But if we had 50 of them, we could then write an array to calculate all the velocities with only 1 line, right? We go through the whole array, we calculate the whole set with 1 line. And it would be a bit tedious, we have to use files without an array. Okay, so we'll start with a simple program to demonstrate how memory is allocated for an array. So in this program, we're going to do a few things. First of all, we're going to declare an array. Okay, declaration. Then we'll see how memory is allocated for the array. And finally, we will show where the reserved memory, and then we'll print out these memory locations. Okay? Great. Okay. Actually, I should have Raheem hitting my button for me so I don't have to keep walking back. Okay, why don't you just hit my button? I can keep wandering all over the place. Okay. All right. So here's our first piece of coding. I'll give you about 2 or 3 minutes to look through the source code and the output, okay, of this. Okay, now as we look at it, you can see first of all, as we start, we have our 2 lines of comments. Then we are including stdio.h because of the printf statement. Then we have a constant macro. This is wherever n occurs in the program, replace it by 6. Okay? This allows you to change the size of the array very easily, just by changing n at the very beginning of your program. We then start the program integer main void, that we declare a integer, j, container, then we declare an array. That's the C hard bracket, square bracket, and square bracket is declaring an array, and then we're just going to print out in a loop each element of the array. We're going to show the index and where that is stored in memory, so you can see the address thing. So let's look at the variable pointer diagram for that. Variable pointer, back, sorry. Back. Okay, sorry. Okay, so, sorry about that. Okay, yes. Okay. All right, so there's our V, so if I'm going to look through this code, let's step through it very quickly. Okay, skip the automatic. Okay, here we go.
宣告一个整数 J，
I'm sorry, it's not loud enough. Very loud, is it?
宣告一个矩阵 C，
Okay, so you see how the variable pointer diagram works. This declared a pointer C, and said it's going to point to 1, 2, 3, 4, 5, 6 pieces of memory. Okay, and you can see how it's been allocated. Memory location FFF2, FFF4, FFF6, FFF8, FFFA, and FFFB have all been allocated now. Okay, has been said the program can now have these pieces of memory. Now, I ask you
印
to
出
do a
名
print.
字、形态和记忆体位置。
The volume is less.
Do we have a volume here? Yes, volume. Okay, let's get our volume next.
Yes.
Let's get our volume, see how that works. Okay, let's try that better, see how that works.
宣告一个矩阵 C， 印出名字、形态和记忆体位置。使用 for 回圈，从 j 等于0开始，到 j 小于6，总共进行6次。
Okay, so we're gonna loop it 6 times.
印出矩阵 C 里，形态是整数，记忆体位置是 FFF2。输入 j 等于1。印出矩阵 C1， 形态是整数，记忆体位置是 FFF4。输入 j 等于2。 印出矩阵 C2， 形态是整数，记忆体位置是 FFF6。输入 j 等于3。印出矩阵 C3， 形态是整数，记忆体位置是 FFF8。输入 j 等于4。印出矩阵 C4， 形态是整数。 记忆体位置是 FFFA， 输入 j 等于5，印出矩阵 C5， 形态是整数，记忆体位置是 FFFB， 结束回传指令。
Okay. Alright, so there's our. So, what do we learn from this code? Obviously, we look at this code there. I got a reason I got you looking at this because I want you to learn something. Okay? Basically, the thing I want you to learn here is basically a few things. One, memory is allocated sequentially. Element 3 follows element 2, follows element 1. Okay? Each piece of memory follows the other one. Like 2 is that the second piece of memory is after the first, after the second, after the third, after the fourth. Secondly, why does the address jump by 2 each time? Because in this Arduino chip, memory at each integer takes 2 bytes of memory. For this computer running, okay, I should say Arduino computer, our little expressive chip, each time it's 2 bytes of memory. And note that arrays are always contiguous. So let's say I'm going to try to see if I can, is this going to run okay? I'm not sure. If I got my exe is going to run correctly or not. We'll try. No, he's not. I don't have him, so I don't bring him. Okay? I don't think okay? Let's look at the objectives now of this unit. I want you to learn to represent arrays using VP diagrams, and I want to explain array declaration, memory allocation, initialization, and usage. Remember, for variables, we just have declaration, initialization, usage. We have an extra thing here, memory allocation. It's an extra step here for arrays. Okay? And I'm going to show you how pointer and array notation are equivalent. Okay, so in Chinese, does this work? In Chinese. There we go. 这个我们的学习的目标. Okay, where's our expert here?
在这个单元，我们将使用 VT 图表现阵列，说明宣告及记忆体的配置，阵列的使用及初始化，说明指标与阵列的等价标记。这单元之后，你将学到画出 VT 图的一个阵列，使用阵列写出一个电脑程式，自由的转换阵列及指标。
Thank you very much. I like your Chinese. Sounds so nice. Okay. All right. At least to me it sounds nice. Is it nice Chinese, Alex? It is. Okay, good. All right. All right. Okay, great. Okay, and after this module, you should be able to draw the VP diagram of an array, write a computer program using arrays, and convert between array and pointer notation. Okay, that's our objectives. Okay, let's start. Here's a VP diagram of an array with 8 elements. Each element is represented by a variable. You can see each of the elements of the array is represented by a variable here. And the variables are stacked on each other. One variable on top of the other. So because it's contiguous memory. And none of the variables have a name or a handle. Okay? There's no variable with a name or a handle in an array. How do we access the array? A pointer is directed to the first element. It's the only thing we have a handle for. Okay, so now you start to understand why we study pointers. Because pointers are needed for arrays. In C and in Python. Even you can't see it in Python. In C I can show it to you. In Python it doesn't let you see it. It hides it. Okay? Don't know why. Pointers are wonderful. Okay? So here's our pointer. He's pointing at the first thing. It's the only thing with a handle. So the only way to access a variable, array element, is via the pointer. Okay? We can only use the pointer to get to the array element. Okay? So access is by a pointer plus an offset. So the pointer plus 0, pointer plus 1, pointer plus 2, pointer plus 3, pointer plus 4, pointer plus 5, pointer plus 6, pointer plus 7. And note, array elements could also be pointers too if you want to make things more complicated. Okay? Array elements don't have to be variables, you could also make them pointers, or pointers to pointers to pointers to pointers to pointers, or whatever you want, etc. Alright, so how do we go to usage? We need to declare the array first. We need to allocate memory for the array. We need to initialize the array. Then we can use the array. We have to have 4 steps. Okay? For variables it was, what are our steps for variables, guys? First step for variables was? Declare, right. After we declare, what do we do, Daniel? No, for variable. Variables, not arrays. Allocate is for arrays. If a variable, after I declare, what do I do next? Yeah, initialization, very good. And then 3, we can use it. Yes, good. All right, so for our array, we're adding one more step. Allocation of memory. Okay, so there are 2 ways of allocating. One is called static memory allocation, and the other is dynamic memory allocation. Okay, so for static memory location, memory is games, thank you. All right. For static memory allocation, the memory is allocated at the same time as the array is declared. So you declare and allocate memory at the same time. As a consequence, the programmer needs to know how much memory is required in advance. Okay, dynamic memory allocation, the memory is allocated at runtime. So when the program runs, it allocates memory. Alright, so this allows more efficient memory usage. For example, if I only have a class of 10 people, I only need to make an array for 10 people. If like in Malaysia, I have a class of 500 people studying this class. So for 500, I need to have an array of 500 people, 500 long, to hold the marks for that class. So the memory is allocated when the program is run. So this is a little bit slower, but can allow us to use memory more efficiently. Okay, moving on. Okay, any questions? No. Okay, so our following code is going to demonstrate the declaration of a static array. We will declare the array and give static memory allocation. We will fill it with values and fill it with values. As you look at this code, please think about the following questions. What is a 1D array and how is it declared? How do we distinguish between 1D and multi-D arrays? What is the first index of an array in ANSI? Why are we getting error messages when we go to outside an array? Why are we using a constant macro? How do we print arrays and how do I dynamically allocate memory? So these are the questions we'll look at as we see the code. We'll hopefully answer. Okay, please spend a few minutes looking through the code. Okay, let's start at the very beginning and walk through it. I just want to highlight a couple of things in the code. Again, you see the constant macro, which says replace everywhere in this text file. You see capital N, replace it with the number 3. We then filled it with values, and then we printed past the end of the array. And you can actually, and we see what did that. And if we wanted to run it, we would be able to print. This is basically the output that we would print. Okay? C0, C1, C2, C3, integer, FF0, FF12, FF4, FF6, 0, 1, 2, 3, 44. Okay? Let's look at our BP diagram. OK。
定义 n 为3为本题要求的数字。 主程式开头，所有主要程式码都打在这里。宣告一个整数 J， 宣告一个整数阵列 AN。
Should be CN, okay? C, okay. So it's
宣告 A0 为0，把 A0 的值设为0。宣告 A1 为1，把 A1 的值设为1。
So we're putting number 2 into the
宣
second
告
condition.
A2 为2，把 A2 的值设为2。显示出 name type address value， 让执行程式后，在画面显示出 name type address value。
Okay, so this is what the array looks like in memory right here. We've got J stored right here at the beginning, then we've got C0, C1, C2, each array with position.
一个回圈由0至 n， 回圈由0开始执行，每执行一次 J 就加1，一直加到 J 等于 n， 停止这个回圈，然后跳出。依序显示出阵列 A0、A1、A2、A3 的值与位置，依照回圈跑的顺序列出阵列 A0、A1、A2、A3 记忆体位置，所以要用 AND、AJ 来输出。
And there's C2, and now so you can see here, we just do one extra time, so now we're looking at what we're getting the memory location at FFF6, which is not in the array, but we can still print the memory location. No problem. We can still access it, we can still write there if we wanted to. Alright, and then return 0. Okay, some questions, all these questions that we're looking at. What is a 1D array? It's a collection of the same type of variables or pointers stored in contiguous and increasing memory locations. So that, like, this is our little 3-element array, C0, C1, C2. Its attributes, it has a name, C. It is a size. It is a type, integer. It is a dimension. In this case, it's 1 dimension. And it's got a number of elements. In this case, it's 3 elements. So here's how we declare the array. We have the type. We have the name of the handle. We have how much memory do we need to reserve. And, okay, so we have 3 pieces of memory, but there's no such thing as C3. C3 doesn't exist. It goes to C2 because arrays go 0, 1, 2 in C. And we have how many dimensions we want. So if we wanted to have, we can do up to 12 dimensions in C. So you can work in 12 dimension space if you want. In C it's a little bit confusing, so I don't recommend it, but generally people don't go over 3 dimensions. Right? So enough, 3 dimensions is quite plenty. Okay, so in general it's the type, name, and number of elements here for a 1-dimensional array. How do we distinguish 1 and multi-dimensional arrays? Number of hard brackets. So for example, 1 dimension, 2 dimension, 3 dimension, 4 dimensions, and I guess you can gather a 12-dimensional array is going to look like 1. Okay, first index of an array is 0 because arrays are a pointer. Why? A pointer to the first element plus an offset. Right? So the offset is 0, so the index of the first array is 0. And, okay, and why no error messages when we access an element outside the array? Because when C compiles your program, it thinks in terms of pointers, not arrays. So when C is running, it's thinking in pointers and not arrays. The reason it does it this way is for speed. Any language like Python that's thinking about arrays is going to go slow. Okay? C is designed for speed. Okay? So since it's designed for speed, it's not going to say. So what it does is when you declare a static array, very simply, C sends a message to the operating system. And the operating system, okay, the program says, operating system, please give me some memory. And then the operating system says, here's the memory, and here's a pointer to the first place in the memory that I gave you. And then C forgets how much memory has been reserved. It just remembers, oh, this is the position I can start using in memory. From the, okay, so that's why we're talking about this. Okay, so say I just asked Windows for 3 pieces of memory. Windows returns a pointer, the address of the first piece of memory. I then store that address and then completely forget everything else. Okay, why not? It's like a Keras. Because it allows programs to run faster, and the result you can read anywhere. So this is a Keras. Keras, it's a very interesting thing for fighting. The idea is you jab somebody with it, turn it 90 degrees and pull out. So you can basically pull up, you kind of twist 90 degrees to pull out their stomach. Okay, it sort of does a much better job of killing somebody than just jabbing them and pulling it back out. Because you can't really stitch the wound anymore after you pull out their stomach. Okay. Alright, so, okay. Alright, we use a constant macro to define the array to make program debugging easier. It's easier to see when accessing an out of range element if you have a constant symbol rather than a number used. So if I want an array that's 525 long, I can easily type 523 somewhere else and I can't find that mistake. If I use N or N everywhere, I can just find the errors much quicker. And I can also change program easier. If I write a program for handling the marks of 400 students and my class goes up to 450 students, I only need to make one change at the beginning of my program. Okay, and alright, how do we print arrays? We can't print a whole array with one command. We have to print an array element by element. So we need to use a for loop, a loop to print arrays. This is different from Python. Python, you can print a whole array with one without doing this. In C, you must do a for loop to do it. Because you have to specify what elements you want to actually print. Okay, and so we did sort of a loop we would use. Okay, how do I dynamically allocate memory? This is the last point I want to make. You can see here, this is an example of the code. Take a quick look at it, you see it's slightly different. First of all, I've declared a pointer, Jane, and then I send a message called malloc, which is a library function that goes directly to Windows, and says, Windows, I want you to give me 3 pieces of memory the size of an integer, and return a pointer to the first piece of memory you gave me. And so this will be basically exactly the same as static allocation, but you can see I've broken it into half, and I don't have to know how much memory I need when I start my program running. So allocation follows declaration. Okay, so it's 2-step this time. Okay, and we'll talk more about this next week. Okay, bye-bye. And remember to leave your milestone here, please. So we'll use it for attendance. Okay, I can use it for attendance. Okay, if you want to take a photograph of it, take a picture of it, but leave your sheet here so we need to use for attendance. Okay, so we don't mark you absent. Okay, thank you.